Hi everyone, this is Sushmita, Assistant Professor, Department of Biomedical Engineering from Rogini College of Engineering and Technology. Okay, in this presentation, I am going to explain you about the plethysmography types, then nemography, then ground force sensors, ground reaction force sensors. Okay, first thing is inductive plethysmography. Okay, inductive plethysmography is a non-invasive method for measuring the changes in volume of a body part such as arm or leg. Okay, this inductive plethysmography is mainly used for measuring the volume changes in a body part. Okay, this technique mainly involves placing an inductive plethysmographic coil. Okay, this inductive plethysmographic coil is a very small electromagnetic device. Okay, this can be placed around the body part to be measured. Okay, as the body part changes in volume, the coil detects the changes in electrical conductivity and produces a signal that can be recorded and analyzed. Okay, we need to place this inductive plethysmography coil in the place we need to measure the volume. Okay, if there is a change in a body part volume, the coil will detect the changes in the electrical conductivity and produces a signal, and that can be recorded. Okay, this is mainly used for measuring the volume changes during the exercise or any other activity. Okay, this will provide the important information about the muscle function and the performance of a muscle. Okay, then it is also used in research settings for studying the respiratory function and the changes in the thoracic or abdominal volume while breathing. Okay, this is very simple technique, plus it is non-invasive and reliable method for measuring the changes in the body volume. Okay, it is also used in clinical and research settings. Okay, this is an pictorial representation of a inductive plethysmograph. Here they are having the electroglottograph, okay, and a microphone for measuring the volume changes in the thoracic region. Okay, this is also a pictorial representation of a inductive plethysmography. Here they are connecting oscillators, then it is calibrated and demodulated, and it is sent to the analog to digital converter, then microprocessor. Okay, then we can view the volume changes in a TB monitor. Okay, again it can be stored or in a CRT, and then it can be stored in a floppy disk or a hard copy. Okay, the next thing is impedance plethysmography. Okay, this is also a non-invasive technique. This will measure the changes in the electrical impedance across the tissue or a body part in response to the blood flow. Okay, this is also used for measuring the blood volume changes in the body. Okay, during this impedance plethysmography test, we need to place the electrodes on the skin. Then a small electric current is passed through the tissue. Then the resulting changes in impedance will be recorded and analyzed. Okay, this will provide the information about the blood flow and volume in that particular area. Okay, here we need to place an electrode in the area of interest. Then they are passing a very small amount of current. Okay, so due to this there will be a changes in the impedance. Okay, this will be recorded. Okay, this will provide information about the volume changes in the area of interest. Okay, this is mainly used to monitor and diagnose conditions such as DVT, okay, that is deep vein thrombosis, then arterial insufficiency and vascular malformation. Okay, it is a simple and reasonably accurate diagnostic tool, although it is not as commonly used as other non-invasive vascular tests such as Doppler ultrasound. Okay, here we are using the electrodes and we are passing a small amount of current. Then the changes in inductance will be measured in accordance with the volume changes in the body. Okay, this is a block diagram for the impedance plethysmography. Okay, here there are electrodes, then preamplifier for amplifying the signals, then demodulator, then there is another one amplifier for amplifying and filtering, then analog to digital converter. Finally, the results can be viewed in a PC. Then nemography. Okay, nemography is a diagnostic technique. This also involves the measuring and recording of various respiratory parameters. Okay, it will include measurement of carbon dioxide, oxygen level, then lung volume measurement, then lung capacity, airway resistance and air pressure. Okay, this nemography can be performed by various methods. Okay, these methods mainly includes spirometry and body plethysmography. Okay, this is mainly used for diagnosing the respiratory disorders. Okay, mainly COPD. Okay, COPD in the sense chronic obstructive pulmonary disease. Okay, then asthma, then pulmonary fibrosis. Okay, this is mainly used for measuring the breathing patterns and lung function. It also measure the physiological changes associated with the breathing. Okay, usually here we will place a nemograph around the chest or abdomen, and it will measures the volume of the air inhaled and exhaled by the patient. Okay, then the data will be collected by the nemograph, is analyzed by a healthcare professional to determine the lung function of a patient. Okay, then they will diagnose the respiratory conditions such as asthma, COPD, sleep apnea, etc. Okay, this is a block diagram for nemograph. Okay, here also electrode should be placed in the chest cavity. Then voltage to current converter is there, then oscillator, then instrumentation amplifier, then notch filter, full wave demodulator and low pass filters are there. The next thing is wearable ground reaction force sensor. Okay, this is a device that can be on the foot or ankle to measure the force applied by the ground on the foot during walking, running or jumping. Okay, this sensor is mainly composed of a very small electronic device that is attached to the body. This one will detect the vertical, horizontal and medial lateral components of a ground reaction force. Okay, this sensor will gather information about the biomechanics of movement. Okay, it will include timing, magnitude of force and it will provide a valuable information about the gait analysis. Okay, gait analysis in the sense is a walking pattern and rehabilitation. It is mainly used in sports, physical therapy, research. Okay, this sensor, we can use this sensor along with the wearable devices such as smart shoes, then fitness tracker. Okay, for enhancing the accuracy and breadth of data collection. Okay, this type of sensor is designed to measure the forces that are exerted on the ground. Okay, this type of force is ground reaction forces. Okay, it will occurs during running, walking and jumping. Okay, this sensors will detect the force that is exerted on the sensor when the foot hits the ground. Okay, when the foot hits the ground, this pressure sensors will detect that particular force. Okay, then this data will be collected by the sensor. This will give information about the gait. Okay, gait means walking pattern of that particular individual, then timing, magnitude of the force that is exerted on the ground. Okay, to use this sensor, the person need to attach the sensor to their foot or ankle by using a straps or adhesive. Okay, once the sensor is in place, the individual can begin their activity as normal and sensor will begin to collect the data. The data collected by the sensor will be transmitted to the computer or any mobile devices. Okay, then it will give feedback regarding the person's gait movement. Okay, gait movement in the sense walking pattern. Okay, this is very much useful in analyzing the walking pattern of a patient. Thank you all.